All right, so we're going to start with example 7, which has to do with the area of a parallelogram. So the formula for area of a parallelogram, so I'm just going to highlight this here, is base times height. Okay, and it's really important here that we identify, I'm just going to put a little note here, that the base and height must be perpendicular. You can either write this sign, which means perpendicular, or write out the word. Okay, what does that mean? So I'll give you an example. So let's say you have a parallelogram, and I'm going to do a harder example so we've got more than we need so that way we know what to use. So let's say we have a parallelogram and you're given this unit is, I'm just going to make up some numbers. So let's say this is 10. Let's say this bottom here is 20, and let's say the side is 15. And we're needing to find the area of this. So the area for a parallelogram is base times height. So we have 3 numbers, but we really only need 2. And you need to look out for the numbers of the sides that are perpendicular to each other. So see this little right angle symbol here? That tells us that this side, 10, is perpendicular to this side 20. So 20 is going to be your base and 10 is going to be your height. Now keep in mind, it doesn't necessarily, the base doesn't have to be on the bottom. Like I could have drawn the parallelogram like this, okay? And I could have, said this was 10 and this was 20. So don't get fooled. The shapes can be written or drawn in different directions. In this case, the 10 and the 20 would still be the base and the height. So height isn't necessarily vertical, it's just what forms that right angle with the other side. So look for that right angle and that'll give you a clue as to what to use. So looking ahead, so let's look at example 7. So it says to estimate the area of each parallelogram by visualizing the number of 1 centimeter by 1 centimeter squares. So that means, one of these squares. How many of these squares would make up this parallelogram? So this is a good activity because this is, this is basically asking students, like if you were doing this with kids, this is a good way to start area because it's requiring them to really estimate, which is good, and then also just get an idea of what area means as opposed to just plugging and chugging using a formula, which, a lot of times we're just going through the motions and not really thinking about what it means. So, you could divide the shape up and identify where the squares are. So you just kind of, and this is an estimate, so maybe, I don't know, maybe for this first one I say, okay, I've got, here's 1, here's 1, here's 1, here's 1, here's 1, here's 1. And maybe I say that this one, those together look like maybe they're about a square, and this looks like it's maybe about a square. So all together it looks like I've got 1, 2, 3, 4, 5, 6, and then 7, 8. So maybe about 8 square centimeters, I would guess. And then if I did the same thing here, maybe this is 1, and maybe, I don't know, this is 1, 2, 3, 4, 5, and then maybe this is 6, 7, so maybe about 7. And again, this is just an estimate. So I would start by estimating, and then I'm going to erase this. I'm going to go ahead and I'm going to use my formula. So I'm going to write area. So this is for number 1, area equals base times height, and I'm going to find a measurement that's perpendicular to another measurement. So I know that the bottom is 4, and I'm told that this height, so it would be this distance, is 2. And that's what I want. I do not want the diagonal. I want the vertical distance of 2 because that's perpendicular to 4. And I know it's perpendicular because of these squares here. So it meets this bottom at a 90-degree angle. So I'm going to say area is equal to my base, which is 4, and my height is 2, so I get an area of 8 square centimeters. So I was right. So my estimate was the same. Doesn't always happen, but that's great. So number 2, I'm going to do the same thing. So area is base times height. Now I'm told this measurement is 2, and I'm also told this distance is 3.5. It's also the same as here. So the height doesn't necessarily have to be inside the figure. These arrows are still telling us how tall it is, and that's that line makes a right angle with this measurement at the bottom. So the area for this one is going to be the base of 2 centimeters and a height of 3.5. So I end up getting 7 centimeters squared there too. All right, so for number 8, we're told that the area of a parallelogram, so as soon as I read that, I'm just going to write down the formula. Area equals base times height. So the area is 24 square centimeters, so that's going to go in for area. And the base is 4, so I'm going to plug those in. Find the height, so we don't know what that is. So 24 equals 4 times h. You can solve this equation by solving for h, so I'm going to divide both sides by 4, so those cancel out, and I'm left with 6 is equal to h. And if the area is in square centimeters, then that would be 6 centimeters. Okay, so I'm going to go down and I'm going to do one more shape here. So we've got area of a triangle, and the formula for area of a triangle is 1/2 base times height, or 1/2 BH. And I'm going to make the same note I did for the parallelogram. So base and height must be perpendicular. And I'm going to give you an example. So let's say I have a triangle that looks like this, okay? And maybe it's labeled like this. So maybe that's 10, I don't know, that's 12. I'm making up all of these numbers, and this is 25, okay? You've got more than you need. What you want to eyeball is, okay, where is that right angle? Okay, that means 10 must be the height, and 25 must be the base. It has no bearing, like the fact that the 10 is sort of up and down isn't what makes it the height. It makes it, the right angle is what makes it the height. So I would do 1/2 the base of 25 and the height of 10 in this example. So, oh, and I'm looking at this right now, I did see that. The note is already on your notes, but you could highlight that since it's important. And just to mention, you know, where that formula comes from, remember that the area for a parallelogram, so for a parallelogram, which looks like this, is base times height. Well, a triangle is half of a parallelogram. I can't talk. So the area for a triangle, or half of it, would just be 1/2 base times height. So that's where that formula comes from. And then let's look at example 9. So for this one, I'm going to write down the formula. So area equals 1/2 base times height. This is my base. That's my height, so I'm just going to multiply those together. So it's going to be 1/2 times 5.8 times 2, or 5.8 square centimeters. For this one, looks like I'm looking at 2.9 and 4 because those form that right angle. So area is equal to 1/2 base times height, and I'm also left with 5.8 square centimeters. Okay, and then last but not least, we've got the isosceles triangle, and this one's a little bit harder. So it's harder because notice there's no right angle. Okay, you've got to figure out what the height is because you're not given the height. So what I would do is I'm going to draw a height in and make a right angle. And the nice thing about an isosceles triangle is we know that this side is equal to this side, so this is also 34. And if we drop, this is called an angle bisector, down the middle, then this side right here is the same distance as this. So if all together it's 32, then we know that this is 16 and this is 16. And then now we have two right triangles. So I'm going to draw one of these right triangles just outside here so we have a little bit more room. So we've got 16 and 34, and I want to find the height. That's the side that I'm looking to find. So we're going to have to use the Pythagorean Theorem. And this is a theorem that you should have learned about in Math 148. So it's a squared plus b squared equals c squared. C is always the hypotenuse, which is the longest side. And you know that it's the longest side because it's the side that's opposite from the right angle. So if the right angle is here, the side opposite is 34. And it usually looks like the longest, but it's nice sometimes to use that right angle trick since it's not always obvious, or you might be second guessing. So in this case, the 34 goes by itself, and then we can put the 16 squared plus, you can call it b squared, you can call it h squared, it doesn't really matter what letter you use at this point. So 16 squared is going to be 256. Plus b squared is equal to 34 squared, which is 1,156. We want to get b squared by itself, so I'm going to subtract 256 from both sides, and that leaves me with b squared equals 900. And then I want to undo the square, so the opposite of squaring is square rooting. So I square root both sides, and I'm left with b equals 30. So that's going to be the height. So I'm going to come over here, and I'm going to write 30. Okay, so 30 is my height. So the area of the triangle is 1/2 base times height. We know the height is 30. Now the base has to be 32. So this is important because you're given 34 and 32, but we want the 32. I'm just going to highlight this because that's what forms that right angle with the 30. Just get my highlighter off here. Okay, so I'm going to write, let's see, 32 there. And then if you multiply that all out, you should get 480 square millimeters. So just a couple of things. Again, if you don't see the right angle when you're given the problem, you may have to get creative and divide it up into triangles and use the Pythagorean theorem. The Pythagorean theorem only works with right triangles. So keep that in mind.